The question says that a nucleus is at rest in laboratory frame of reference. Show that if it disintegrates into two smaller nuclei, the product must move in opposite directions. So the question is underlining the theory of conservation of momentum, which states that total momentum of a system of interacting particles is conserved. So it says that if a system has let's say particle m1, m2, m3, and if it is isolated and the net force acting on the system is 0, so the momentum is always conserved, or the change in momentum is equals to 0. So in our case over here there is a nuclei and it disintegrates into two smaller nuclei. So let us assume that the smaller nuclei has mass m1 and m2. So according to conservation of momentum, its initial momentum is equals to final momentum, or P initial is equals to 0, and that will be equal to P final. Now P, the momentum, can be stated as mv1 plus mv2, where v1 and v2 is the velocity of mass m1 and m2, m1 v1 plus m2 v2. So according to conservation of momentum, P initial equals to P final, or P initial is equals to 0 equals to m1 v1 plus m2 v2. Now we have to show that the velocity of one particle is in opposite direction of the velocity of another particle if the particle disintegrates. So let us assume that in the final stage the particle disassociates. So v1 can be given by the expression minus m2 v2 divided by m1. So here m1 and m2 are constants, and v1 and v2, their direction is, the sign is opposite, so we can say that the direction of v1 is opposite to the direction of v2. So according to the conservation of momentum, we have proved that the velocity of the particle will be in opposite direction given the momentum is conserved. Thank you.